Okay, so this definition is going to diverge slightly from our book. So instead of defining what a general polynomial is, we're just going to define one with integral coefficients, and then we'll go back and we'll amend this definition later on. So what is a polynomial in X with integral coefficients? Well, it looks like uh, the following. So is an expression of the form P of x is a0 plus a1x plus a2x squared plus. The ellipsis means keep adding till you find a stopping point where the top coefficient is non-zero. If it was 0, we wouldn't write it. We'd go to the next one. So we just demand the top coefficient is non-zero. And these a0, a1, all the way up to an, these are coefficients like you know them from polynomials, but they're integral, so they're in z. And that's what it is. So it's an expression of that form. And some other things that we can attach to this is we say the degree of p is n, and that's a definition of degree. It's just the uh, degree of the leading term. And we refer to a0 to an, as I've said. These are coefficients of p. And if we want to think about all possible polynomials with integral coefficients, we have notation for that. So the set of all polynomials in X with integer coefficients is z adjoint x, and it's the collection of all of these p of x's. So n is some, it could be that the degree is 0, so n is allowed to be 0, so we are going to include 0, and each of the a's are integral. So just for to write down some examples of this set of polynomials with integer coefficients. Things like, I don't know, 2 plus 3x squared minus or plus negative 4x to the 5 is in this set. Things like, x to the 2024 minus or plus negative 2024 x to the 2025 are in this set. I'm just writing down some random elements here. Okay, and I'm writing, instead of writing subtraction here, which is fine if that's what you want to write, that's fine. But we need to make sure that the expression that we write is of the following form. So it's number plus number times x plus number and so on. And so you could object even to what I've written down so far. Technically, what we should write, this expression 2 plus 3x squared plus negative 4x to the fifth is not of the right form. Technically, this should be 2 plus 0x plus plus 3x squared plus 0x cubed plus 0x to the fourth plus negative 4x to the 5. And so this guy now is in the right form, and if we want to use the language we had earlier, the degree is 5, because that's the top term here, and the coefficients are 2, 0, 3, 0, 0, negative 4. Now, I'm not going to write that out for the second polynomial because it's understood that when we don't write the power, the coefficient is 0. But technically, this guy has 0 as the coefficient all for the first 2024 terms, and then the 2025th term has a 1 as a coefficient, and the 2026 term has a negative 2024 as a coefficient. Okay. All right, so those are examples. And usually we won't write out the terms that have a 0 as a coefficient. And I also want to point out another example, just so it's there. We could have something like -5 as our polynomial. That's in the right form. And this guy has degree 0 and just one coefficient. It's just the coefficient of the constant of the x to the 0 power, if you like. The coefficient's just -5. Okay, so we can have constant polynomials as well. And actually here we're actually seeing something happen. Sort of the integers on their own we can view sort of naturally as a subset of the set of all polynomials with in x with integer coefficients. And so that'll be a theme that we'll explore a little bit later in the section, but I just want to observe it now. So these are what this is what the collection of all polynomials in X is, and we have a way of adding and multiplying these guys that we'll talk about in the next video.